Last time we talked about bar plots and pie charts, and those were graphs for qualitative data. Today we'll talk about the types of graphs you would make for quantitative data. There's two situations that I want you to be aware of. The first situation here, the data here represents the number of cars in a household. So we went to a bunch of households and asked people, how many cars do you have in your house? And these were the answers. If I look at my data set, notice that there's not a lot of different answers. I see a 0, a 1, a 2, a 3, a 4, and that's it. So that's all the possible answers in my data set. So this situation is a situation where we have discrete data with just a few possible values. So in this situation where we don't have that many different answers, we can just list all the answers. So we said we saw some 0s, some 1s, some 2s, some 3s, and some 4s. And let me title this column. This data represents number of cars, which means this 0, 1, 2, 3, and 4 represents number of cars. And we'll find the frequencies. Frequency means how many, so we're just going to count how many zeros are in my data set, how many ones, and so on. Now, on your lab, we're going to use R to help us count. So let me just tell you what the frequencies are. If you count, there are 9 zeros, there are 24 ones, 19 twos, 5 threes, and 3 fours. And that's how you find the frequencies for situation 1. I'm going to call it ungrouped data. Now, let me skip to situation 2 so that I can tell you the difference. Now, situation 2, the data we have here is number of hours per week that students spend studying. So we asked a bunch of students, how many hours per week do you study? And these are the answers. Now notice, if I look at the data set here, there's a whole bunch of different answers, right? This is actually continuous data. And continuous data, remember, is data where you can have any possible decimal as an answer. So 5.138 makes sense as a number of hours. So when you have continuous data, you can't possibly list all the decimals. There's just too many. So in a situation where either you have continuous data, or if you have discrete data where there's just too many possible values, what we'll do is we'll break up the data into groups, or chunks, or ranges, like these. So this situation is called group data, where we're breaking up the data into groups or chunks or ranges. So here I broke up the data into chunks for you, and let's actually title this column. And the question is, what do these numbers represent? These numbers represent the number of hours spent per week studying. So this is number of hours per week. And we're going to find our frequencies also. So we're going to count how many data values are between 2 and 14.9. How many data values are between 15 and 27.9. So I'm going to tell you the frequencies, but if you actually do count, you'll find that there are 4 data values that are between 2 and 14.9. There are 10 between 15 and 27.9. There's 13 between 28 and 40.9, 9 between 41 and 53.9, and 2 between 54 and 66.9. Okay? And that's frequencies for the grouped data situation. Now, the rest of the table is computed the same way for both situations. So let me just explain it for situation 1, and I'll just tell you the answers for the situation 2. Because the process is exactly the same. Now, just like when we talked about qualitative data, frequency, right? We know that there's 9 households that have 0 cars. Question is that we often ask is, what percent does that represent? So what percent of households have 0 cars? And that's called a relative frequency. And the way you calculate the relative frequency, the first thing you need to do is find out how many people total in your sample. Now, or how many households in this case in your sample. You could go and just count 1, 2, 3, 4, 5 all the way through, but if you know the frequencies, if you add up the frequencies, that's going to tell you how many people total in your sample. Because these frequencies are counting how many people. In this case, we're counting how many households. All right, so let's add up our frequencies. Once again, the calculator that I'm going to recommend is the Decimal Scientific Calculator. There'll be a link on your lab, and it looks like this. So add up the frequencies. 9 plus 24 plus 19 plus 5 plus 3. 60. So there's 60 households in my sample here. To find the relative frequencies, you're going to take each frequency and divide it by the total. So the first one, 9 over 60. 0.15. Next up, 24 divided by 60. And I get 0.4. Next up, 19 divided by the total. So 19 divided by 60. Here I do get a long decimal. Remember, we're going to round to 3 decimal places. This is 0.317. Next up, 5 divided by 60. Rounded to 3 decimal places. This is 0.083. And then finally, 3 divided by the total number of people. 0.05. And then remember, in the previous lecture when we talked about the qualitative data, I said if you end up with decimals that you don't have to round, add on zeros at the end so that every number has the same number of decimal places. So I'm going to add on until I get 3 decimal places on each one. And that is just going to help me when I actually have to compare. So these are the relative frequencies. The next thing I want to calculate for so we calculate frequency and relative frequency for qualitative data also. Now for quantitative data, there's 2 other things that I can calculate. The first of which is cumulative frequency. And you've heard the word cumulative before. So at the end of every semester, when you get your GPA, you have 2 GPAs. You have a regular GPA and you have a cumulative GPA. So your regular GPA is your GPA for that semester. Your cumulative GPA includes all your classes in previous semesters also, right? So it includes everything before also. Many of you have asked me, is the final exam cumulative? So what you're asking me is, does the final exam cover everything before also? So everything from the beginning of the semester also. So cumulative frequency, the first cumulative frequency is going to be the same as the regular frequency. Now, for the next cumulative frequency, we're going to take the 24, but also include everything before it. So I'm going to do 24 plus 9. Okay, so 24 plus 9. Which is 33. The next cumulative frequency, 19 plus everything before it, so 19 plus 24 plus 9. 52. Next, 5 plus 19 plus 24 plus 9. 57. Next, 3 plus 5 plus 19 plus 24 plus 9. And as a shortcut, at each step, what you can do is just take your cumulative frequency, because this 57, remember, already includes 5, 19, 24, 9, and you just add on the next frequency. So you just do 57 plus 3. Or you can just do 3 plus everything else. I'll do it the long way. 3 plus 5 plus 19 plus 24 plus 9. and that you get 60. And that's the cumulative frequency. We'll talk about the interpretation of this a little bit later on. And then finally, we can also talk about the cumulative relative frequency. And anytime you see the word relative frequency, you're basically converting to a percent. So we're going to take all these cumulative frequencies and divide it by the total number of households or people in the sample. So 9 divided by the total, 9 divided by 60. (0.15). 33 divided by 60. 0.55. Next up, 52 divided by 60. Rounded to 3 decimal places, this is 0.867. Next up, 57 divided by 60. 0.95. Next up, 60 divided by 60. I should know this one. This is 1. And then just like before, I want to add on zeros at the end so that everything has 3 decimal places. So I'm going to add on a 0 right here, a 0 right here. 867 already has 3, 950, 1.00. Okay, and that's just going to help me if I need to compare these numbers later on. Let me now fill in the table for situation 2. The process is exactly the same. So let me just show you the answers. All right, and that's the table for situation 2. Now, there's some vocabulary that I need to introduce for the situation 2, where we're talking about grouped data. And grouped data, remember, is we're just breaking up the data into ranges here. How many classes are there? Okay, so classes are just ranges. So this is just asking how many ranges are there. That's 1 range, 2, 3, 4, 5. There's 5 ranges. What is the class width? Before I talk about class width, let me actually introduce some more terminology here. These ranges, or classes, right? So these are called classes. These classes, they have a low number and a high number. The low number is called the lower limits. Okay, so these are the low number in each range. The high number in each range are called the upper limits. Now, the class width is the distance from a lower limit to the next lower limit. Okay, so how far is it from a lower to the next lower? So how far is it from 2 to 15? How far is it from 15 to 28? So how far is it from 2 to 15? How would you find that? Well, what you can do is take 15, which is the next lower, subtract off the previous lower. So 15 minus 2. And you get 13. And you can do that anywhere. So pick any of the lowers, 28, and then subtract the previous lower. So 28 minus 15. And you'll see that it's also 13. 41 minus 28, also 13. 54 minus 41, also 13. You can actually also do it with the uppers. So if I take any of the uppers, say 40.9, subtract 27.9, the previous upper, also 13. So the 13 is really telling me that in this table, the lowers are going up by 13, the uppers are going up by 13. So everything in my table is going up by the same amount, and that's the class width. Next up, midpoints. The formula to find the midpoints is lower plus next lower divided by 2. That's the formula. So we're going to find the midpoint, and these refer to the midpoints of each of these ranges. Okay, so you should have one midpoint for each range. So we have 1, 2, 3, 4, 5 ranges or classes. I should have 5 midpoints. The first one, lower plus next lower divided by 2. Okay, so that means I'm going to do lower, so 2, plus the next lower, 15, divided by 2. All right, let me take out my calculator. And so I recommend using the decimal scientific calculator because you can just type it in exactly like you see it here. So I'm going to type in the fraction. There's a fraction button in the right-hand side here. Fraction up top, 2 plus 15, and the bottom, 2. Okay, type it in exactly like you see it here, and I get 8.5. The next midpoint is going to be 15 plus 28 divided by 2. So 15 plus the next lower, which is 28, divided by 2. All right, on my calculator, fraction up top, 15 plus 28. On the bottom, 2. 21.5. Next one, 28 plus the next lower, 41, divided by 2. So 28 plus 41 over 2. Okay, fraction up top, 28 plus 41 over 2. 34.5. Next one, 41 plus 54 divided by 2. Fraction, 41 plus 54 on top, 2 on the bottom, 47.5. Okay, we're not done. So I said you should have one midpoint for each range. Okay, there are 1, 2, 3, 4, 5 ranges. I have so far 1, 2, 3, 4 midpoints. I need one more midpoint for this last range. So 54 plus what? There's no more lowers. So what do you do? Well, the next lower should come right after this upper. So what's the number that is right after 66.9? 67, right? So you can do it that way. So 54 plus 67 over 2, 60.5. Okay, that's one way to do it. Another way to do it is we know the class width, right? So if once you know how much each of the lowers are going up by, right? We know it's going from 2 to 15 is 13, 15 to 28 is 13. That's the class width. Once you know the class width, everything on your table, well, not everything, not these, but everything on this side is going to go up by 13 also. So notice that 8.5 to 21.5, right? If I subtract those, 21.5 minus 8.5, 13, right? If I subtract 34.5 minus 21.5, it's 13, okay? The midpoints are also going up by 13, going up by 13. So what does this mean? This means that we can actually save some time. So all you really need to do is use the formula to get that first midpoint. Once you know that first midpoint and you know the class width, all you need to do is just keep on adding 13, right? So 8.5, add 13, it's 21.5, okay? It's Start with 21.5, add 13 again. 34.5, okay? Add 13 again, so 34.5 plus 13, 47.5. So that's another way, a quicker way to get the midpoints. Use the formula, get that first one, figure out the class width, which is just the distance from a lower to the next lower, right? Subtract those, 15 minus 2, that will give you the class width. Once you know your class width, just keep on adding the class width, and that will get you the rest of the midpoints. The main type of graphs for quantitative data are the histograms. And there's two variations depending on whether you're in situation 1 with the ungrouped data or situation 2 with the grouped data. Let me start with situation 1. So situation 1, ungrouped data, is a situation where the possible values are not that many so that you can list them all. Okay, so if you can list them all, we're going to start off by putting all those possible values on the x-axis. So on my x-axis, my possible values are 0, 1, 2, 3, and 4. Okay, and let me title my x-axis. These numbers represent number of cars. So my x-axis is number of cars. Now this is called a frequency histogram, which means I should be putting frequency on the y-axis. And if I look at my frequencies, I have 9, 24, 19, 5, 3. So when I number my frequencies, I need to go all the way up to 24. Now, you can count by 1s, you can count by 2s, by 5s, by 10s, as long as you get up to that 24. So I'm going to count by 5s. 5, 10, 15, 20, 25. Okay, and then for each value here, you're going to make a bar. So 0, frequency is 9. I'm going to make a bar of height 9. Next up is the 1, frequency 24. I need a bar of height 24. Okay, couple things to note here. Unlike the bar plot in the previous lecture when we were talking about qualitative data, notice that the bars touch. There's no gaps. Okay, so that's one thing. And also notice that the numbers on the x-axis are in the center of the bar. Okay, so this is true for ungrouped data. Next up is 2. Frequency is 19, so I need a bar height 19. 3, frequency is 5. And then the 4, frequency 3. And to help my reader, because sometimes the height is hard to read, I'm going to put the frequencies on each bar. So the 0 was supposed to be 9. The 1 was a 24. The 2 was a 19. The 3 was a 5. And then the 4 was a 3. Okay, so once again, for ungrouped data, first of all, the bars should touch. Meaning there's no gaps. Okay, this is different than a bar plot for qualitative data in the last lecture. And then for ungrouped data, the bars should be centered over the numbers on the x-axis. And that's a frequency histogram for the ungrouped data situation. Now let me skip over to the group data situation and let me show you what's different. Okay, group data situation, this was our situation where we had to break up the data into ranges here. Okay, so when you have to break up the data into ranges, what you're going to put on the x-axis are the lower limits, which are the lower number in each range. So we're going to put 2, 15, 28, 41, 54. So 2, 15, 28, 41, 54. Okay? Once again, these are the lower limits. And let me also title what these numbers mean. So these numbers were number of hours per week. We're talking about a frequency histogram. That means we're going to put frequency on the y-axis. Now for this situation, if I look at my frequencies, 4, 10, 13, 9, 2. So I need to get up to 13. This one I can count by twos, I think. I'll count by twos. 2, 4, 6, 8, 10, 12, 14. And now, the first frequency is a 4, okay? This 4 represents the range 2 to 14.9. So when I make my bar, I want that bar to be over the range 2 to 14.9. So 2 to 14.9 is like 2 to the just to the left of that 15. But I'm just going to make it go all the way up to the 15. So our first bar is frequency 4. My second frequency, 10, okay, that represents the range from 15 to 27.9. So basically from 15 to 28. So I need a bar, height 10, from 15 to 28. Okay, so from 15 to 28, height 10. Okay, notice the difference. Well, similarity, the bars touch. In the first situation, when we have ungrouped data, the bar is centered above the number, or the numbers are centered on the bars. And that's because in that situation, the frequency 9 represents just a 0, okay? So this bar goes just with the 0. Okay, and that's situation 1, ungrouped data. Situation 2, right, notice that the numbers are not in the center of the bars. And that's because in the group data situation, each frequency doesn't represent a single number. Right? Each frequency represents a range of numbers, so that each bar should be over that range. So the bar here is over that range. The next bar is over the next range. All right, so let's finish up this histogram. The next one is the 13. That represents the range 28 to 40.9, but on the picture it's going to be 28 to 41. So 28 to 41, height is supposed to be 13. Next one is 9, representing 41 to 54. 41 to 54, 9. And then we still have one more, right? I still have this 2. So this 2 represents 54 to something. So height 2. And you should put the number that goes right here. So 54 to what? What would be the next lower limit? There's a couple ways you can find out. The next lower limit, okay, we know that all these numbers are going up by 13. So the next one should be just 13 away. So 54 plus 13, which is 67. Or we also, the other way we talked about on the previous page was the next lower limit should be just to the right of this last number here, 66.9. So the number just to the right of it will be 67. Okay, 67. And these are the lower limits. Now let me label the bars just to help my reader figure out the height. The first one was a 4 frequency. Next one was a 10, 13, 9, and 2. And that's a frequency histogram for the second situation of group data. And let me write down the key points that I was talking about. Same as for both situations, the bars touch. No gaps. So for quantitative data, the bars touch. For qualitative data, that we talked about in the last lecture, the bars have gaps. Okay, and that's for qualitative data. Now, for group data, the bars are over ranges. I'm going to say the class ranges. Numbers are not centered on bars. No numbers centered on bars. Okay, so make sure you understand the difference between these two situations. The situation for ungrouped data, where you have the numbers at the center of the bars, and the situation for group data, where you have the bars over a range and you don't have any numbers at the center of the bars. Now, let me go back and do the other variation, relative frequency histograms for both situations. Now, the only difference is in a frequency histogram, you put the frequency on the y-axis. In a relative frequency histogram, you put relative frequency. That's the only difference. So relative frequency. Okay, we're in situation 1 here, so we're talking about these cars. Okay, you can list out all possible values, so we're going to list them on the x-axis. 0, 1, 2, 3, 4. I'm going to title the x-axis. These represent number of cars. Relative frequency. These are my decimals here, 0.150, 0.400, 317, and so on. The way I number relative frequency is the same for in all cases. I'm just going to go by 0.100, 0.200, 0.300, 0.400, 0.500, and so on. And I need to go up to 150, 400, 317, 400. So I think I'm good. And now my bars. The 0 was 0.150, so I think of it as like 150. So 150 would be between a 100 and 200. And remember, this is situation 1. Situation 1, I'm going to have the numbers in the center of the bars. Next up, 400. Next up, 317. So 317. That should be right here. The 083. 083, 83. So that should be below the 100. And then finally the 4050, that's 50. That should be below the 100 also. And then I'm going to label the bars with the relative frequencies. 0.150, 0.400, 0.317, 0.083, 0.050. So once again, if you end up with decimals that are where you don't have to round, my recommendation is add on zeros so that every decimal has the same number of decimal places. In this case, every decimal has three decimal places. It's going to help you compare and graph. Now, let's go to situation 2 and make a relative frequency histogram for this one. So I'm going to put relative frequency on the y-axis. This is situation 2, where I have grouped data, which just means that the data is broken up into ranges. This situation, we're going to put just the lower limits on the x-axis. So these are 2, 15, 28, 41, 54. 2, 15, 28, 41, 54. And then relative frequency, these are my decimals here, and I number them the same way at all times. So I'm going to go up by 0.100, 0.200, 0.300, 0.400, and let's see, I need to get up to 342. So I think I'm good there. Now, first one, 105, 0.105. Remember, this one goes with the range 2 to 15. So the bar should be above the range 2 to 15. 105. Okay, notice that there's no numbers in the center of my bars. The bar is over the range 2 to 15. Next up is 263. That should be over the range 15 to 28. 15 to 28. 263. Next up is 0.342. That should be over the range 28 to 41. 342. Next up, 237. That's going to be over the range 41 to 53.9, which is about 54. So over 41 to 54.237. Okay, I'm not done because I haven't made a bar for this last one, which is 0.053. That should be over the range 54 to something. What is this something? Okay, 54 to the next lower limit. Next lower limit should be just right after this 66.9, which is 67. Or you can also get it by 54. These numbers are all going up by the same amount, so just add on that same amount. In this case, the numbers are going up by 13. So 54 plus 13 will be 67. And this last one will be 0.053, 53. That should be below the 100. And then I'm going to label my bars. The first bar is 0.105. Next bar, 0.263. Next one is 0.342. Next one is 0.237. And then 0.053. And then I should also title the bottom, which I forgot to do. These numbers represented number of hours per week. Let's talk about how to interpret these graphs now. I'm back on the ungrouped data situation, and I want you to write a sentence interpreting the second bar on the histogram. So I'm talking about second bar, that's this 0.400, and this 24. So usually when I interpret, I like to go back to the table. So let's go back to the table for this situation, which was on the first page. And I want to interpret the 24 and this 0.400, which is right here. So I want to interpret this 24 and this 0.400 frequency. So the type of sentence I want you to write is, this 24 is counting how many, we're talking about households here. So how many households? So there's 24 households. And what's special about these households? So there's 24 households. What's special about these 24 households? They have one car. So I'm looking for 24, and then what's special about them? They have one car. Now, the 0.400, so anytime we are interpreting a relative frequency, right, I want you to convert it to a percent. So we're going to move the decimal point 2 to the right, which is the same thing as just multiplying by 100. 2 to the right, it's 40.0, so that's 40%, 40.0%. So 40.0% of the households. And what's special about these 40%? These 40% have one car. 40% of the households have one car. So I'm looking for the 40% that you converted to a percent, and then what's special about the 40%? They have one car. Now, let's go to the ungrouped data situation. So, the group data situation. And in this situation, I'm looking for you to write a sentence interpreting the third bar on a histogram. So 1, 2, 3, I'm talking about this 0.342 and this 13. Okay, let's go back to the table. So we want to interpret the 13, which is this one, and the 0.342, which is right here. Okay. 13, so this is counting how many, so there's 13. What are we talking about here? These are coming from a sample of students, so there's 13 students. So the 13 is, there are 13 students. And what's special about these 13 students? These 13 students spend between 28 and 40.9 hours per week studying. So these 13 students spend between 28 and 40.9 hours per week studying. Okay, I'm looking for the 13, and then what's special about these 13? They spend between 28 and 40.9 hours per week studying. Now, the 0.342, which is right here, okay, anytime we're interpreting a relative frequency, I want you to convert it to a percent. So multiply by 100, which is the same thing as moving the decimal point 2 to the right. So 2 to the right, it'll be 34.2. So 34.2% of students. And what's special about these 34.2% students? They spend between 28 and 40.9 hours per week studying. So I'm looking for you to convert it to a percent and then tell me what's special about these 34.2%. They spend between 28 and 40.9 hours per week studying. Let's now talk about how to interpret the cumulative frequency and the cumulative relative frequency. And I want to do this for both situations, the ungrouped data situation and the group data situation. Let's start off with the ungrouped data situation. So this is our situation with the households and how many cars each household has. And let's interpret this 57 cumulative frequency and this 0.950 cumulative relative frequency. Now, this 57, remember, how did we get this 57? We got this 57 by adding the 5 with everything before it, right? So we did 5 plus 19 plus 24 plus 9. So this 57 is not just counting the number of people that have 3 cars. It also includes the number of people that have 2 cars, 1 car, 0 car. So this 57 is counting the number of people who have 3 cars or less, okay? So we're gonna write there are 57, and I keep on saying people, but in that first situation, we're talking about households. So there's 57 households, And what's special about these 57 households? These 57 households have 3 cars or less. So what I'm looking for is the 57, and what's special about these 57 households? They have 3 cars or less. So anytime you're interpreting a cumulative frequency, you always have to throw in that or less phrase, right? Because cumulative means that it includes everything before it, right? Or less. And now for the 0.950, okay, anytime we're interpreting a relative frequency, I want you to convert it to a percent. Okay, convert 0.950, convert it to a percent, move the decimal 2 to the right. That's 95.0. So 95.0% of households. And then same thing. This 95%, right, does not include just the 3, right? It includes the 3 or less. So 95% of households have 3 cars or less. Okay, I'm looking for you to convert to percent. And then what's special about this 95%? They have 3 cars or less. And once again, anytime you're interpreting anything that involves the word cumulative, you should always include the phrase or less. All right, so now let's interpret some cumulative frequencies and cumulative relative frequencies in the second situation with group data. So here we're talking about number of hours that students study per week. Okay, it's group data because we're breaking up our data into ranges. And let's interpret this 27 and this 0.711. Okay, 27. Now, once again, this 27, we got this 27 by adding 13 and everything before it. So 13 plus 10 plus 4. So this 27 is not just these people who are doing 28 to 40.9. It also includes this range and also this range. Okay, so these 27 students spend 40.9 hours or less. Okay, these 27 students spend 40.9 hours or less per week studying. You said it was 27? Who spend, because it includes this range and then everything before it. So the easy way to write that is to say 40.9 hours or less. Okay, so I'm looking for the 27 and then this phrase, 40 hours or less. Anytime you're interpreting something that has the word cumulative, you always have to throw in the or less phrase. And then the 0.711, okay, anytime you're doing relative frequency of any sort, convert it to a percent. So move the decimal 2 to the right. That'll be 71.1%. 71.1% of students spend 40.9 hours or less per week studying. Okay, I'm looking for you to convert to a percent. And then what's special about these 71.1%? They spend 40.9 hours or less per week studying. And anytime you're doing anything that has the word cumulative, throw in the word or less. We'll need some vocabulary now to describe the shape of histograms. Skewness refers to the location of the tail. So here's a histogram. I have a peak here, and then this part here on the left side is called the tail. So when I have a peak on the right side and the tails on the left side, that's called skewed left. Picture on the right, the peak is on the left side, that's the tail on the right side, okay? Peak's on the left side, the tail's on the right side, that's called skewed right. Okay? Location of the tail is the direction of the skew. First picture, the tail's on the left side, skewed left. Picture on the right, tail's on the right side, skewed right. Picture in the middle, we have a peak in the middle and two tails that are equally on both sides. This is called symmetric. Now in the lab, I asked you, in terms of grades, would you like the grade for this class to be skewed left or skewed right? Okay. Speaking of grades in this class, do you want the grades to be skewed left or skewed right? So now let's talk about what skewed left really means and what skewed right really means. Skewed left. So most of the data is where? Right? The heights of the bars are telling you how many of the data you have. So I have a high bar on the right side. So most of the data is high. And then you have a few that are on the low side. That's skewed left. Okay? Most of the data is on the high side, and then you have a few data on the left side. Skewed right, the peak is on the left side. That means you have most of the data is on the low side. And then you have a few that's high. So speaking of grades, do you want grades that are mostly low and then a few that are high? Or do you want grades that are mostly high and a few low? Or do you want grades that are in the middle and then you have a few high and a few low? That's, you decide. Next vocabulary I want to talk about is modes. So modes refers to how many peaks, the number of peaks. First picture here, there's one peak. It's called unimodal. So uni meaning one, unimode, no. Second picture, there's two peaks. So one right here, one right here. It's called bimodal. So bi meaning two, bimodal. Example one. Here we have some data. This data represents the monthly charges for long distance phone calls. Construct a frequency, relative frequency, and cumulative relative frequency distribution. Distribution just means make a table that has all these things. Using class width of 3 and using 7 as the lower class limit of the first class. Now, let's go back to situation 2 where we were talking about the group data and we broke up the data into ranges. Okay, these ranges are called classes. The lower number in each range is called a lower limit. The upper number in each range is the upper limit. And we also noticed that the lower numbers are all going up by the same amount. The uppers are also going up by the same amount, and that amount is the class width. So what this is telling you to do is to break up the data into ranges, and I'm telling you how right here, okay? Class width of 3. So when I make my ranges, my lowers should go up by 3, my uppers should go up by 3. 7 as the lower class limit of the first class. That's saying make 7 the lower number of the first range. So my first range, I want it to be the 7 to be the lower number of that first range. Okay, I don't know what the upper number is yet, and I don't need to know right now. So class width tells me I want my lowers to go up by 3. So let's make the lowers first. I don't know how many I need, so let me just do a couple. My lowers go up by 3. So 7 plus 3 is 10, plus 3 is 13, plus 3, 16, plus 3, 19. And I don't think I need to go any more because if I look at my data here, it only goes up to 16.53. So I think I should be good ending at 19. Now, how do you get the uppers? Okay, this upper number should be slightly below this 10. Okay, what number is slightly below 10? 9. Now, if I look at my data, notice that my data has two decimal points. Okay, your uppers should have the same decimal places as your data. My data has 2 decimal places. I want my data to also, or my uppers to also have 2 decimal places. So what number is just below 10 with 2 decimal places? 9.99. Okay, that's just below 10, and it has 2 decimal places. The next one should be just below 13. What's just below 13? 12.99. What number is just below 16? 15.99. What number is just below 19? 18.99. And then I should have one more upper. How do you get this upper? Well, use your class width. Class width says that my uppers should go up by 3. And they are, right? 9 to 12 is 3. 12 to 15 is 3. 15 to 18 is 3. 18 plus another 3 would be what? 21.99. Okay, those are my ranges. And then I need to do my frequency. Okay, frequency is just going to count how many are between 7 and 9.99. So we're going to count. That's between. And I think that's it. So there's 2 numbers between 7 and 9.99. And then let me tell you the other ones. There's 3 between 10 and 12.99, 5 between 13 and 15.99, and 2 between 16 and 18.99. And it turns out that we didn't have any data that's between 19 and 21.99. So we actually didn't really need that one anyway. And then we're going to find relative frequency, cumulative frequency, and cumulative relative frequency. And the way you do it is exactly the same as on the first couple pages that we talked about at the beginning of the lecture. So I won't do it here. Example 2. If I give you a histogram, can you go backwards and make me a table? So the first question I want to ask is, which situation is this? Is this a situation with the ungrouped data, or is this a situation with the grouped data? Notice that the bar is over a range. Okay, so that bar represents a range, which means this is going to be the grouped data situation where we're going to have ranges. Okay, and the question is, how do we make these ranges? If I go back to histograms for group data, remember that I said the numbers on the x-axis are the lower limits. That means that these numbers on the x-axis are lower limits. And lower limits just means that these numbers are the lower number of each range, which in my ranges are going to be 15 to something, 30 to something, 45 to something, 60 to something, 75 to something, 90 to something. Now, how do I find my uppers? Okay, so just like in the previous example, this upper should be slightly below this 30. So what number is slightly below 30? 29. And in the previous example, I said that your upper should have the same number of decimal places as your data. But here, we're only given the histogram. We're not given the data, so I actually don't know how many decimal places to use. So you can choose. You can choose 1 decimal place, 2 decimal places, 3 decimal places. That's fine. So 29.9, you can also do 29.99. You can also do 29.999, or even more than that. The next one should be slightly below the 45. That's going to be 44. And I'm going to choose to use 1 decimal place here, so 44.9. Next one, slightly below 60. That's going to be 59.9. Next one slightly below 75, 74, whoops, 74.9. The next one slightly below the 90, that's going to be 89.9. And then there's one more here. How would you find this last one? Well, figure out your class width. The lowers are all going up by how much? 15 to 30, that's going up by how much? You just subtract 30 minus 15 is 15, right? So it's going up by 15. From 30 to 45, that's going up by how much? So subtract 45 minus 30, that's also 15. Okay, 45 to 60, that's also 15. 60 to 75, that's also 15. So my lowers are all going up by 15. That means the class width is 15. That means my uppers should also go up by 15. Okay, so to find this last one, we're going to go up by 15. So 89.9 plus 15. 104.9. And let me also title this, this column. These numbers we got from these numbers right here, and they represented miles. So all these numbers are miles. And then we're going to find a frequency. Now, this is a frequency histogram, okay, which means the heights represent the frequency. So the 12 is the frequency of the range 15 to about 30. So 15 to 29.9, that frequency should be 12. Okay, the frequency for 30 to 44.9, 30 to 44.9 is 3. And then next one will be 4, 3, 2. I guess we didn't need this last one anyway. And then we'll need to find a relative frequency, cumulative frequency, and cumulative relative frequency, which is the same process as that we did on the first 2 pages. That's it for today. Have a great day. See you next time.